Okay, so question number 4 is if u equal to u is a function of sine square root of x plus square root of y, right? So that x del u by del x plus y del u by del y equal to 1 by 2 square root of x plus square root of y times cos square root of x plus square root of y. Solution. Now first note that this given function is homogeneous or non-homogeneous, right? If you replace x by tx and y by ty, then you will find that you are not able to completely take e to the power half common out of the function, right? Due to the presence of this sine function present here. So it is something like FOG. This is your F, this is your G. So this is like FOG. And G is homogeneous of degree 1 by 2, but F is not, of course, because sine of Tx is not equal to T sine x. Okay. So what is stopping you to have this overall function U as a homogeneous function? F is stopping you actually. The problem is created by this sine function, right? So if you are able to get rid of this sine function, suppose you take it here, then it will be converted into a homogeneous function, but that will be a function sine u, sine inverse u, right? Okay, so just observe that, note that u tx comma ty cannot be expressed as t to the power n u x comma y. You can observe this, and this is just due to the presence of the sine function, right? I will write this due to sine function. We call it sine function. Okay, but if you if you take this sine inverse sine on the left hand side, then it will become sine inverse of u is equal to square root of x plus square root of y, and let you assume it w, right? W. Now you see that this is clearly homogeneous. This function is clearly homogeneous of degree, right? Clearly, W is homogeneous in x comma y of degree 1 by 2, right? That is W of tx comma ty equal to t to the power half times wxy, right? Okay, so by using Euler's theorem on W, right, we'll be having x del W by del x plus y del W upon del y equal to n times W, right? And now just put the value of W. Value of W is actually sine inverse u y del upon del y sine inverse u equal to half sine inverse u. Okay. Now differentiation of sine inverse u is, what is the differentiation of sine inverse x? Anybody? Anybody?
क्या
Differentiation of sine inverse u.
1 u square.
Yeah, and del u by del x will be there, right? 1 upon under root 1 minus u square multiplied with del u by del y will be there, is equal to half of sine inverse u, right? Okay, now just bring this under root 1 minus u square by multiplying to its right hand side, you will be getting x ux plus y uy equal to 1 upon 2 1 minus u square root times sine inverse u. See, the answer is in the form of x and y, because originally the function was given in terms of x and y. Now just put the values of u here. You can see that the value of sine inverse u is this much, root x plus root y. We can put that value 1 upon 2 under root 1 minus, right? U square is actually sine square root x plus root y. And sine inverse u is nothing but it is actually root x plus root y. Okay, and 1 minus sine square theta is cos square theta, and the square root of cos square theta will be cos theta, cos root x plus root y times root x plus root y. Okay, so if you want to write it like this, root x plus root y can be written before, and then you can write cos of root x plus root y. So this is what we wanted to prove, right? Okay, so this is an example where the given function u was non-homogeneous, but that can be converted into homogeneous by bringing that function f here, right? Question number 5. U, and this time u is a function of 3 variables actually, x, y, and z, and you have log e, and then sine, and then pi 2 x square plus y square plus xz whole to the power half divided by 2 x square plus xy plus yz plus z square whole to the power 1 by 3, and this is actually the angle of sine, right? To that x ux plus y uy plus z uz is equal to e to the power minus u square root of 1 minus e to the power 2u, sorry, this is in the power actually 2u divided by 3, and it's multiplied by sine inverse e to the power u, right? So solution. Again observe that this function, overall this function is non-homogeneous. In this time, this is of the form, this is your function f, this is your g, and this is your h, right? You can see that h is homogeneous actually. If you find the degree of h, then that will be homogeneous, and you can always express h. H can be expressed as t to the power something times h something, sorry, that something is, I think, is 2 1 by 2 1 minus 2 by 3, and that is 1 by 3. Yeah, you can express h in this form, but this is non-homogeneous, this is non-homogeneous. Of course, sine is the function, sine is stopping you to get that t to the power 3 by 1 by 3 outside, and again log is sitting there, that is again stopping you to get that t to the power 1 by 3 just out of the overall function, right? Just because of these two functions f and g, you have this overall function, this u is non-homogeneous function. But fortunately, the good thing is that the function present inside most the function present on the extreme right, you can say the function which will be operated first, right, which is considered first. This is the first function f g h, this is h, and this is homogeneous of degree 1 by 3, right? So that's give us a hope that Euler's theorem can be applied on the modified version of this function. So we have to modify this function actually. We can take this log and this sine function, we can remove the sine and log and take them to the left hand side, and then we can have a homogeneous function, so that we can apply this Euler's theorem, right? So see that it's again a note. U is non-homogeneous as u, x, y, z cannot be expressed as e to the power something times u, x, y, z, just because of the presence of these two transcendental functions. These are called transcendental functions, right? Okay. Generally, they behave like this. They always restrict e to the power n to get outside of the bracket, right? Okay. But the good thing is that the most inner function is homogeneous, right? So what I will do, I will just do some modification, like I will just take this log on the left hand side, right? And whenever you take log on the left hand side, that will be the inverse of log is exponential function. So that will be if you bring this log on the left hand side, then this u will be e to the power u, because when you take anti-log on both sides, then you have e to the power. Exponential is actually the inverse of log, you know this, right? And then you will bring this sign on the left hand side, then this will become sine inverse e to the power u, right? So actually I will be writing the result after two simultaneous steps, right? So what I will write, I will write see pi 2 x square plus y square xz to the power half, and 2 times x square plus xy 2yz z square to the power 1 by 3, right? And see, if you bring this log, let me write it here, sine. Let me bring this log on the left hand side, then what it will give? It will give e to the power u is equal to this much, right? And in the very next step, you will again bring this sign here. That will give you what? That will give you sine inverse e to the power u is equal to this much, and that is assumed as w. Clearly, w is homogeneous in x, y, z of degree. Can you find the degree of this? If you find it directly, you will see that the degree of this polynomial in three variables is 2, and 2 to the power half will be the degree which will be obtained from the numerator, and from denominator you will be having 2 to the power 1 by 3, sorry, something like this, 2 to the power 1 by 3, right? So ultimately that will be sorry, I have done something wrong actually. 1 will be the degree, and here the degree is 2 by 3. So 1 minus 2 by 3 will be 1 by 3. Let me prove it. Degree 1 by 3, and I am giving a small proof for this, as the reason is this. See, w dx dy dz is equal to, see, pi 2 x square dy square plus tx dz whole to the power half divided by 2 tx square plus tx dy plus 2 dy dz plus tz whole square whole to the power 1 by 3. Okay, now see, it will be pi by 2. You can see that t square can be taken common throughout this numerator, right? But half is sitting here. T square to the power half will be t only, right? And in denominator, you can see that t square can be taken common, and then 1 by 3 is on the exponent, right? So eventually that will be t to the power 2 by 3, right? And let me write this I by 2 times whatever you have, so that will be w x y z. So if you subtract the exponent, that will be 1 minus 2 by 3, that will be 1 by 3 w x y z. So you can see that this number is 1 by 3. That's why the degree is 1 by 3. That was mentioned earlier, right? Okay, now you can apply Euler's theorem on w, and that will give you x del w by del x plus y del w by del y plus z del w by del z. Do not forget that you have 3 variables this time, so please do not forget this writing this third term, right? Because z is already involved here. Okay, so that will be n times of w. Now let us put the value of w. What is the value of w in terms of u? That is this much, sine inverse e2. And please pay attention, do not put this value. I never substituted this value in terms of x, y, z anywhere in my calculation, because if you are putting this value, then you have to differentiate it, and differentiation of this will be quite difficult. Differentiation of this is relatively easy, right? So please do not substitute this value, just substitute this function of u, right? That gives you x del by del x, and the value of w is sine inverse e to the power u, and then again y del by del y sine inverse e to the power u, z del by del z sine inverse e to the power u is equal to 1 upon 3 sine inverse e to the power u. Now you have to differentiate it, but I'm not writing the whole calculation here. This differentiation of this thing will be 1 upon under root 1 minus eu whole square, that will be e to the power 2u, right? And differentiation of this angle will be e to the power u, and then differentiation of this exponent will be del u by del x, right? And this will be done for all the 3 terms, right? And so after taking common, I will be getting something like this. I've just skipped one step, but you can understand how this is valid, right? I've just differentiated each of the 3 terms and then take this common. Of course, this will be common in each of these 3 terms, right? Now, so that gives me this whole term can be brought on the right hand side. So I will be having x ux plus y uy plus z uz is equal to 1 by 3 there, and square root of 1 minus e to the power 2u will be there, and this e to the power u will be in the denominator, but rather than writing it in denominator, I should bring it in the numerator like this, e to the power minus u, and then sine inverse e to the power u. Is it what we are required to prove? Yes, I think exactly same result. Yes, only we prove this. For u, and this is a function of 2 variables x and y, that is cosec inverse x to the power half plus y to the power half divided by x to the power 1 by 3 plus y to the power 1 by 3, and this whole thing has been kept inside the square root, right? Okay, this is a cosec inverse this much. Okay, prove that x square uxx 2xy uxy plus y square uyy, okay, is equal to 10 u multiplied with the 13 plus square u whole divided by 1 4. And note that this is a second order derivative relationship. So we'll be using that deduction we derived yesterday in this numerical. But to use that deduction, we ultimately rely on Euler's theorem. But again, my question is to Mr. Vikat Raj. Is he here today?
Yes,
Vikat
sir.
Raj. Okay, Vikat Raj, please answer. Can we apply Euler's theorem to this function directly? I mean, do we require some modification, or this Euler theorem can be applied directly?
No, sir, we require modification.
Okay, so please do that modification. What is that modification? You want to bring this cosec inverse here? Yes.
Yes, sir.
Okay, please tell me. W
Cos
u, because if you are bringing this cosec inverse on the left hand side, it will be cosec only. Inverse is double inverse, right?
yes, sir.
Okay, okay. And here you are left with x. Sorry, plus y to the power half, and then this whole thing is divided by x to the power 1 by 3 plus y to the power 1 by 3, and this whole thing is inside the square root. So can you claim that this is homogeneous? Can you find the degree of this function without actually calculating the degree? We want to do shortcuts.
So I think 1/6 होगी.
तो नीचे की हुई -1/3, पूरे की फिर हाफ भी तो करनी है, पूरा का फिर हाफ भी तो करनी है ना डिग्री. 1/2 minus 1/6 1/12 आएगी इसकी डिग्री. 1/12 will be the degree. W dx comma dy is equal to square root 1/12. कभी कभी क्या होता है कि डिग्री निकालते हुए गलती ना हो, तो इसलिए चेक कर ही लेते, क्रॉस चेक कर लेना चाहिए, क्योंकि मैंने कहा था कि इसमें थोड़ा थोड़ा धोखा भी हो जाता है कभी कभी. क्या 1/12 आएगी, ठीक है. देख लेते हैं निकाल के कॉमन कितना है. एक्चुअली में ये है कि कॉमन कितना है. ऊपर से तो आएगा टी का पावर हाफ, नीचे से टी का पावर 1/3, 1/2 माइनस 1/3 तो टी की पावर 1/6 हो गया. 1/6 और बाहर से पावर हाफ भी है, that will be 1/2. Will be having wx comma y. Please do not forget this square root sign. T to the power half will be common from here. T to the power 1/3 will be common from here. That will be t to the power half minus 1/3. 1/2 minus 1/3 is 1/6. This means t to the power 1/6 will be inside this square root. But t to the power 1/6 and the square root is means 1/2. So that will give you t to the power 12, right? Okay, fine. Now, so the degree is 1/12. That's great. Thus, you can say that W is a homogeneous function, right, in variables x and y of degree equal to 1/12. Now you can comfortably use that Euler's theorem. By Euler's theorem, you'll be having x del w by del x plus y del w by del y is equal to what? Is equal to 1/12 w. Right. And now the value of w, please do not put this value of w. Please don't do this. Right? Just put this value of w, the simplest one. So x del upon del x, and here you will be having the value of w, that is cosec u plus y del upon del y del upon del y cosec u is equal to 1/12 cosec u. Fine. Now differentiate cosec u. What is the differentiation of cosec u? Please tell. Is it minus cos?
Cosec u into cot u.
minus cosec u into cot u. Yeah. Okay, cosec u into cot u. Okay, fine. And x del u by del x, do not forget that you are going to differentiate u also. Del u by del x and y, del u by del y will be inside this bracket, and 1 by 12 cosec u. Now you can bring this but what we are going to do, okay, we have to apply the second derivative. Okay, no problem. X del u by del x plus y del u by del y is equal to, bring that this whole term on the right hand side. So cosec u will be cancelled. You will be left with minus 1 by 12, and cot u, the reciprocal of cot u, will be tan u. And since we are going to use this second order relationship now, you see that this is our target. So we have to assume this as a function, new function g, as we have been doing yesterday. Say, right? Okay, so this is your just half the half the way of your journey, right? Okay, now this is a GU. Now we'll be using that as special result, right? Okay, using that special result, and that special result is x square uxx plus 2xy uxy plus y square uyy is equal to, the formula is gu times g dash u minus 1. So this is the formula we can use directly, and the value of gu is minus 1 by 12 tan u. And the differentiation of this thing, what is the differentiation of tan u? Differentiation of tan u is sec square u. Please note that differentiating with respect to u. This is not partial differentiation, so that you are writing del u by del x here. No, do not write this, right? Just sec square u, because you are differentiating with respect to u here. Okay, minus 1. Now minus can be taken common, so that you will be having 1 by 12 here and 10 u here, and you can take LCM of this thing also. So you will be having sec square u plus 12, and in the denominator you will be having 12. So ultimately 12 multiplied with 12 will be 144. That is what you require. You require 144 in the denominator, and everywhere you need 10 in the numerator, right? So that's your target. Convert everything into 10. 1 by 44, 1 by 144 will be in the denominator, and this is a 10 u, and just replace this sec square u. Sec square u is nothing but it is 1 plus 10 square u plus 12, and that gives you the required result, and u and 13 plus 10 square u, right? Any problem in this question? Any problem in this question? Please ask if you are facing any problem, please.
No sir, no sir.
We should move to the last question. This is my last question now, question number 7th. अगर हम इस सवाल में cosec को sin में कन्वर्ट, cosec को sin में कहाँ से करते हैं कन्वर्ट, कहाँ से, किस स्टेप में कह रहे हैं, which step there is a possibility of converting cosec? हाँ, कहाँ पे?
सर cosec is equal to 1 by sin होता है आंसर?
हाँ, 1 upon sin होता है, बिल्कुल होता है.
यहाँ पे सर आप cosec u लिखे is equal to इतना, सर उसको उल्टा कर देते हैं सर.
उसको 1 upon sin कर लेते, चलो ये 1 upon sin होता तो इसमें तो कोई फर्क पड़ता, यहाँ पड़ता, यहाँ 1 upon sin होता ना, यही कह रहा हूँ, यहाँ पे भी 1 upon sin ही होता, यही.
यस सर.
फिर 1 upon sin u का डिफरेंशिएशन करते हैं तुम, तो 1 upon sin u का डिफरेंशिएशन तुम 1 upon sin x का डिफरेंशिएशन करते थे कि 1 upon sin x को cos x लिख के सीधा कर लोगे.
सर वहाँ पे सिर्फ sin u ही लिखते हैं सर.
कहाँ पे?
cosec q की जगह sin u लिखते हैं. यस सर. उसके बाद इज इक्वल टू वाला को नीचे कर देते हैं
को.
यस सर, यस सर.
हाँ, वो कर सकते थे, वो आप कर, लेकिन तो साइन यू कर देते ना, इसको उल्टा कर देते.
जो प्रूफ करने के लिए वो मैच नहीं होता सर, क्यों रहता?
नहीं हो जाता, वो भी हो जाता, क्योंकि प्रूफ करना है, जो करना है प्रूफ x यू में तो करना है प्रूफ, हो जाता, कर सकते हैं ऐसा, क्यों नहीं कर सकते। बस वो डिग्री अलग आती, फिर डिग्री 12 आती है ना, फिर आपकी ये 1/12 आ रही थी, फिर आपकी 12 डिग्री आती। हाँ लेकिन आ जाता, ऐसा नहीं है, कर सकते हैं, क्यों नहीं कर सकते। अच्छा जी चलें आगे। gx के बाद रिपीट कर दो, gx कहाँ पे लिखा मैंने, अच्छा ये वाला gu के बाद रिपीट कर देते हैं। ओके फाइन, तो आपने gu माना, तो फिर कल वाला रिलेशनशिप, ये जो कल एक डिस्कस कराया था, मैं आपको रिलेशनशिप दिखा देता हूँ पहले। ये वाला, इसमें यह ट्रिपल स्टार लगा रखा है, ये वाला रिलेशनशिप, ये वाला रिलेशनशिप है। ये सेकंड ऑर्डर का जो डेरिवेटिव्स के जो टर्म्स हैं लेफ्ट हैंड साइड में, ये इक्वल होता है gu और ब्रैकेट में g डैश u माइनस 1, ठीक है। और ये gu क्या चीज होती है, gu इज द राइट हैंड साइड ऑफ दिस आयलर थ्योरम, बस ये होता है। gu आपको वो मानना है जो आयलर थ्योरम की राइट हैंड साइड में बना है, और तब आपको ये खूबसूरत सा फॉर्मूला लगा लेना है, बस। तो वही मैंने किया, मैंने राइट हैंड साइड वाले को gu मान लिया, आ गया जी। इसको हमने gu मान लिया, इसको फिर फॉर्मूला लगा दिया और फिर आंसर, ठीक है। प्लस x टू द पावर 4 tan इनवर्स y upon x, right? Find the value of x square 2xx plus 2xy uxy plus y square uyy plus xux plus yuy at the point 1, 1. This is a question which is actually asking you to find the numerical value at the point x। क्या आप मुझे बता सकते हैं ये 1, 1 किसकी वैल्यू है, कौन है ये 1, 1? ये 1 किसके लिए है, ये वाला? हाँ x, y के लिए, ठीक है। आपने जब आंसर हम निकाल लेंगे ना, लास्ट में x को 1 और y को 1 भी रखना पड़ेगा। हाँ x y के लिए, ठीक है। लास्ट में करना पड़ेगा काम, पहले तो वैसे ही चलना है जैसे आप चलते आ रहे हैं, पर पहले ये सोच लीजिए क्या ये दोनों अलग अलग ट्रीट करना पड़ेगा या इकट्ठे ट्रीट होने के लायक हैं। मुझे तो इनकी डिग्री अलग अलग लग रही है दोनों की, पहले वाले की डिग्री 3 है, दूसरे वाले की 4 है, तो ये इकट्ठे तो ट्रीट हो नहीं सकते, दोनों को सेपरेटली ट्रीट करना पड़ेगा, फिर जोड़ना पड़ेगा, ठीक है। तो शुरू वैसे ही करना है, कल भी हमने ऐसे कई क्वेश्चन किए थे जहां पे सेपरेट ट्रीटमेंट पॉसिबल था। तो आपने मान लिया u को मान लिया v प्लस w, ऐसा आपने मान लिया, और ये मानी आपने इक्वेशन नंबर 1, ठीक है। बताना पड़ेगा कि v किसको माना आपने, v माना है आपने इसको, किसको, पहले वाले को x³ sin इनवर्स y अपॉन x को, ये आपका v है। इसकी डिग्री तो सीधी बता दो आप लोग, क्योंकि मुझे नहीं लगता कि इसकी डिग्री आप पहचान नहीं पा रहे हैं। कितनी डिग्री है इसकी? 3। हाँ, इसको चेक करके टाइम वेस्ट क्या करना है। होमोजीनियस ऑफ डिग्री 3, तो आयलर थ्योरम लगा दो जरा जल्दी से इसमें, बाय आयलर्स थ्योरम। हाँ जी लगाइए, बोलो। x del v by del x प्लस y del v by del y इज इक्वल टू 3v। ये तो हुई पहले, इसका भी नंबर डालना पड़ेगा a, इसलिए डालना पड़ेगा क्योंकि क्वेश्चन में ये भी पूछा हुआ है ना, फर्स्ट ऑर्डर का भी पूछा हुआ है। अब दोबारा से वो रिजल्ट लगाओ, देन यूजिंग दैट डिडक्शन जो आपने कल किया था, x स्क्वायर vxx प्लस 2xy vxy प्लस y स्क्वायर vy इक्वल टू, फॉर्मूला होता था gv, सॉरी मैं तो gv लिखने भूल गया, इज इक्वल टू gv मान लिया आपने इसको से, और ये है आपका इक्वेशन नंबर 1, राइट। तो फॉर्मूला था gv ब्रैकेट g डैश v माइनस 1, राइट। आपने वैल्यू डालना है इसका, gv का वैल्यू कितना है, व्हाट इज वैल्यू ऑफ gv का वैल्यू है 3v, g डैश v करेंगे तो 3 आ जाएगा, 3 माइनस 1, ultimately it will be 6v, so let it be equation number b, right? अच्छा, now अब आपने बात करनी है W की, and W is equal to x to the power 4 tan inverse y upon x। ये भी होमोजीनियस नजर आ रहा है और डिग्री इसकी है 4, होमोजीनियस ऑफ डिग्री 4। तो इस पे भी आयलर थ्योरम लग जाएगी बाय आयलर्स थ्योरम ऑन W। x del W by del x प्लस y del W by del y इक्वल टू n का वैल्यू है 4 W। इसको भी मानना पड़ेगा G W से, that should be C, sorry, this is C, okay। वैसे G नाम हमको बदल देना चाहिए, हम G हर जगह यूज कर रहे हैं, इसका नाम कुछ HW मानना चाहिए, एक ही फंक्शन थोड़ी होगा, ये तो अलग दिखने वाला फंक्शन है HW। हमने ऊपर भी ये गलती करी है, ऊपर कल की क्लास में, आज तो नहीं कल की क्लास में, तो फंक्शन का नाम चेंज कर देना चाहिए। हालांकि फर्क कुछ नहीं पड़ रहा है क्योंकि अल्टीमेटली आप कंसिडर तो नया फंक्शन ही कर रहे हैं, लेकिन फिर भी कंसेप्ट के तौर पे अगर ये जीवी है तो फिर ये फिर ये तो नया फंक्शन है, इसका नाम तो बदलना चाहिए ना हमको। एच नाम दे दिया मैंने, ठीक है। देन एक्स स्क्वायर डब्ल्यू एक्स एक्स प्लस 2xy डब्ल्यू एक्स वाई प्लस y square w y is equal to hw h dash w minus 1, right? So what is hw? Hw is actually 4w, and the differentiation of 4w is 4 minus 1, so that gives you 12w. So this is your equation number D, and now we can add all equations A plus B plus C plus D, and on adding them you can see that when you add equation number B and D first, ढंग से देखिएगा, B और D को जब आप add करेंगे, their first terms, then x square will be taken common. Inside bracket we will be having vxx plus wxx, right? Similarly, if the second terms are added, then 2xy can be taken common, and inside bracket you will be having vxy plus wxy. And for the third term, y square is common. Sorry, not w, v actually. V y plus w y plus now add equation number A and C. See the equation number A, and this is equation number C, and you can see that x can be taken common, and inside bracket we will be having vx plus wx, and if you take their consider their second terms, then that will be v y plus w y. This is the result of the left hand side addition. Now add right hand side also. The first is 3v, then you have 6v plus 6v, then you have what is that, 4w, and at last we have 12w. So the total is here 9v, 9 times v plus 16 times w, right? So what should I do? I should put the values of v and w. Yes, I can do that. So that the final value is 9 times the value of v was x cube. I think it was sine inverse y upon x, and plus 16 times x to the power 4 tan inverse y upon x. So this is just the required expression for this thing, but you have to put x equal to 1 and y equal to 1. So now I'm going to put that, put x equal to 1 and y equal to 1 in the last expression, so that of course the left hand side can be repeated, and you can write it as, and of course this can be simplified here like this. That gives you x square, and this is actually v plus w is nothing but that was u double x plus 2xy, this is uxy plus yy plus x ux plus y u y, right? Now if you put x equal to y equal to 1, then you will be getting something like how x equal to 1. This is given in question. Question is telling you at the point. Oh, yeah, given. Okay. So x square uxx plus 2xy. Do not put it on the left hand side. Or should we put it on the left hand side also? Yes, I think if we are putting something in an equation, we have to give that substitution on both sides. Yeah, I think it should be this one, and 2uxy plus uyy plus ux plus uy. Yeah, don't put that x and y1 here because these are derivatives now. Right? Rather you should write like this. Whatever, this is a function actually. U double x will be having some value. I don't know what it will be involving some variables x and y. U double x will be something. Something means it is a derivative. It will be involving x and y, and in that you have to put that x equal to y equal to 1. You can write it like this: 1 comma 1. Here also 1 comma 1. Here also 1 comma 1. Or in general, you can write it like this. Rather than writing them in individual terms, you can write it just putting a big bracket like this, and then 1 comma 1. This is a nice way, right? It means that this is for all terms. Okay, inside will be 9 times sine inverse 1 plus 16 times sine inverse 1. And you know that sine inverse 1, when is the value of sine is 1? Sine is 1 at 90 degrees. Yeah, and 10 is 1 at pi by 4. Yes. So what will be answer? 4, 8 pi plus 9 pi, 70 pi by 2, I think. 17 pi by 2. Right? So this is the final answer. Anybody is having any doubt, then please ask at any step. Okay, so this is it for this lecture. Almost all the problems have been addressed, and these all are applications of Euler's theorem. You have seen that in each question I have used Euler's theorem, sometimes directly and sometimes indirectly. Direct use of Euler's theorem is possible if U is homogeneous function. But if U is not homogeneous, then you have to modify that function. Like we have been modifying in all of these questions. Like we modified this, like bringing that cosec inverse here. This is a part of modification. Right? Okay. So thank you all.